All right, we are looking at 5-4 part 2 today, and we are solving quadratics by completing the square. So I'm going to reiterate. We solve quadratics by graphing. That's when we found the x-intercepts, because that's what x is and y is 0. Then we found solutions to quadratics by the zero product property. We factored, set everything equal to 0, and then we solved by using square roots. But we talked about how we can't always use a square root. So if you look at this example here, I could not solve this with square roots because I have an x squared and an x. And no matter how I move things or do things, I'd have x squared and x. And if I solve for x, I'm stuck with the square root of x. So I can't solve using square roots, but completing the square is a workaround. So we're going to turn it into a perfect square that we can take the square root of. So it says the methods in the previous lessons can only be used for expressions that are perfect squares or a quadratic where b and c are both 0. However, you can use algebra to rewrite your quadratic expressions as a perfect square. So if a quadratic expression is the form x squared plus bx cannot model a square, you can add a term to make it a perfect square. This is called completing the square. So the terminology is that you complete the square, and we're going to solve by doing that. Okay, now if you read it, this is the rule, and you're going to have to know this rule. So I might ask you, like, what's the rule to complete the square? So we have x squared plus bx, and I'm going to say a has to be 1. And then to complete the square, you take b, you divide it by 2, and you square it. Now, it's not just a made-up thing. We'll talk about why it works. So here's your example. I have an x squared plus 6x. I want to figure out what I can add here as a c to make this a perfect square. Now, you can't just go in and just change something, right? Like if you're going to do it to one side, you have to do it to another side, or you have to balance it. I'm just showing you how to complete the square, and then I'm going to show you how to use it. So they took the term that was b, 6, and they divided it by 2. Well, what's 6 divided by 2? 3. And then what do they do with the 3? They square it. And anytime I square something, isn't it going to be a perfect square? 3 squared is 9. Now, why'd I do this? Factor this. If I factor this, the two sets of parentheses, I get x times x. And what are the factors of 9 that add up to 6? 3 and 3. And whenever you have something times itself, we write it as a quantity squared. Do you see that you created a perfect square, right? When something factors like this, it makes that perfect square. So when you complete the square, you've turned something into a perfect square that you can factor. So let me just throw another one up here. If I have something like x squared plus, I don't know, 6x. Is that what we just did? Hold on. Let me try that again. X squared plus 8x. And I say, I want this to be a perfect square. What number can I put there? All right, you're going to take b, and you're going to divide it by 2, and then you're going to square it. Okay, well, what's 8 divided by 2? 4. And what's 4 squared? 16. Okay, now I know that you can do this in your head. You don't need to show it. I'm asking you to show it, especially today. So I took b, I divided it by 2, and then I squared it. 4 squared is 16. Now, why does that work? Why is that b over 2 this rule? If you think about this, guys, what is the square root of 16? 4. I mean, that's what I squared, right? How many 4s do I need to put in here? 2 of them. Why? Well, if you think about this, I'm going to make this a plus and a plus. If you think about this and you FOIL it, x times x is x squared, and the 4 times 4 is your last. But what about the outside? That's 4x. And what about the inside? That's 4x, which adds up to what? 8. So that's why we took the 8 and divided it by 2. I need to know what the factor was that's going to multiply to get there. So it's not a random rule. I'm taking my number and dividing it by 2, and then I'm squaring it because 4 times 4 would give me that 16. And then we always write it as the quantity x plus 4 squared. Now, why am I doing that? Because how do I get rid of a square? Now I can take a square root. So this should remind you of the problems on your homework or your practice that look like this, where the first step was we divided by 5, and we got x minus 2 squared equals 4. Do you see that we're right here now? Now I can come in and take the square root because it's a quantity squared, and I get that x minus 2 equals plus or minus 2, and then I can solve from there. That's our goal. That is what we're working towards. Let me get rid of this. Now, this first problem is a little bit different. We're introing this idea. So it says solving equations by using the square root property. So I'm not completing the square. I am using this to show you what's going to happen. All right, so our problems are not going to look like this. This already is a perfect square. So I'm jumping in saying I'm not setting it equal to 0. Normally we set it equal to 0 to solve by factoring. This factors. So it's going to be x minus 5 and x minus 5, still equal to 27. So we're not setting it equal to 0. I made this problem specifically to show you this. All right, do you see why? Negative times a negative is a positive, negative 5x, there's my negative 10. And then I'm going to write this as a quantity squared, equals 27. So the directions say use the square root property. I can't use the square root property to solve this because of x squared x. But if I can factor it, now I can use the square root property, and my next step would be to take the square root of both sides. And now I'm back to where we were the other day. I have x minus 5 equals a positive or negative, and then I need to break down that 27, so I'm going with 9 and 3. The square root of 9 is 3, keep the square root of 3. And then this is one of the problems that I was talking about. How do we write this answer? I'm stuck with this plus or minus 3 square roots of 3. I'm going to add 5 over, and it's proper to put the 5 at the beginning. Positive 5 plus or minus 3 square roots of 3. That way it's just clear what's underneath the square root and what's not. This is the exact answer, and that's what I'm looking for. Now, if you wanted to check this, typing this squared minus 10 times this is a lot of work. So if I wanted to check it, I would type it in the calculator, and I would get an approximate answer. I would put it in the calculator, so let's do that real quick. 5 plus 3 square roots of 3. And if I add that, I get 10. So x is approximately 10.196. And if I go back in and I do 3 square root, and I'm just doing it in my calculator real quick. If I'm using this calculator, which you will not be allowed to use this type of calculator on the test, and I type it in here, and I just typed in the minus 5 on the outside, it's going to give me this answer back. Oh, you can't see that. So I'm going to hit that double arrow to get that decimal. But again, you're not going to be allowed to use this calculator on the test because it does the roots for you. So you will have to be comfortable using your own brain for roots. So these are the approximate answers. Okay, I'm looking for the exact, but I wanted to show you if I wanted to test my answer, I'd probably approximate it and get close to 27. Okay, so this one's the same idea. Go ahead and take a second and solve using the square root property. Obviously, I can't get this by itself and take the square root, so I'm going to factor it. Take a second, factor it, see if we agree. I think it's good to show this just to double check yourself in your signs. Make sure that all works, and then write it as a perfect square. Now the square is isolated, so I'm going to take the square root of both sides. And this is where we make the mistake. We say x plus 4 equals 7. And then we subtract 4. What am I missing? I took the square root, right? How many answers should I have? I shouldn't just have 7. I should have what? Plus or minus 7. Okay? That's a big deal. It's not just put a plus or minus sign at the end. When I take the square root, I'm saying what square gives me 49? Well, 7 squared gives me 49, and so does negative 7. Okay, when I go to subtract 4, some of you can do it. 7 minus 4, and you're just like, okay, I've got the answer. I've got 3, negative 7 minus 4, negative 11. Now, if that doesn't work for your brain, then go off to the side and show it. X plus 4 equals 7, or x plus 4 equals negative 7. So you can separate them and then subtract 4, and you will see your two answers. So whatever you need to show to get them right, please show it. Okay, so that was solving using square roots and making that a perfect square. Now we're going to change gears and actually get into completing the square. So I am asking you here to complete the square for each expression and then write the results as a binomial square. So we're going to complete the square and then we're going to write it as a binomial squared. You're not solving anything. You're not balancing it. We're just practicing the method of completing the square. Okay, first thing, in order to complete the square, a has to be 1. So you want it to be a 1x squared plus bx, and then we're trying to figure out what c is. What's the rule to complete the square? Take b, divide it by 2, and then what do you do to it? Square it. Okay, so b is negative 2. Divide it by 2, and then square it. All right, there's a reason I'm showing this. What is negative 2 divided by by 2? Negative 1. And what's negative 1 squared? Positive 1. Okay, so there, I completed the square. That's part 1. X squared minus 2x plus 1. That's the first part of my answer. And the second part said write it as a binomial squared. So factor it, guys. How does this factor? No, they should both be minus, shouldn't they? Because don't I need the two negatives to multiply to positive and add up? It should always be the same sign. And then I would write it as x minus 1 quantity squared. Okay, now I want you to notice something. Remember how I took this negative 1 and then I squared it? Whatever number you square, guys, that's your factor. Do you see it? If it's a positive number or a negative number and I square it, that's my factor. So first of all, showing this is important. Second, use your parentheses. We added the 1. You should always be adding the perfect square because it should always be the positive sign. All right, why am I showing you this idea? Well, sometimes you're not going to get a nice number, so you have to keep the fraction. So if you look at this next one, I am going to take 5, and I'm going to divide it by 2, and then I'm going to square it. Now, a lot of us want to take 5 divided by 2 and do 2.5. I don't want that. I want to keep the fraction. All right, what's 5 squared? 25. What's 2 squared? 4. That's what we want. No mixed numbers, no decimals. So when I go to complete the square, I'm writing this as 25 fourths. So I'm going to rewrite this a little bit better. X squared plus 5x plus 25 over 4. And so we have to factor that. And most of us would sort of be like, well, I can't factor a fraction. Yes, you can. So this is it. You have completed the square, but the whole reason to complete the square is so we can factor it as a perfect square. So if I am thinking about this, yes, it is x times x. What did I square to get 25 over 4? I squared 5 over 2. So guess what my factor is? A positive 5 over 2 and a positive 5 over 2. Now, if you think about that, yes, 5 halves times 5 halves, 25 fourths. 5 halves plus 5 halves is 5. Isn't that like 2.5 and 2.5? So whatever number I square helps me with my factor. Okay, so write this as a binomial. Your second part would be x plus 5 halves quantity squared. So you have all the tools you need now to complete or to solve by completing the square. You know how to complete the square. Now we just need to put it to work. So practice completing the square. There's 3 problems for you to try. So complete the square and then factor it. And then we're going to get into solving and using that. All right, every time you complete the square, the a value has to be 1. If a is not 1, you have to divide it out. The rule is to take the b value, which was 4, divide it by 2. So 2 squared is 4. And then I factored it. I double checked that it worked. I checked my signs. Difference here is my b is negative 4. So I'm going to take negative 2 squared. And every time you square a number, it will be positive. So a perfect square always has to end with a positive perfect square. I'm going to factor that, but notice it's x minus 2. See how I squared the negative 2? Negative 2 is my factor. All right, then we have 1 with a fraction. So I'm going to take 3 divided by 2. I'm going to leave it as an improper fraction. I square it to 9/4. That's my perfect square. And then it factors x plus 3 halves, x plus 3 halves. So there is my factor. Whatever I squared is my square root. And 1.5 and 1.5 would add up to my 3x. Okay, so watch those fractions there. Now, here's a quick guide. This isn't going to mean a lot to you, but it will be something you can come back to. The first thing you're going to do is collect the variable terms on one side of the equation and constants on the other. So we're going to start working with equations. So you want it to look like this. A 1x squared, maybe that's not going to work there. You want it to be a 1x squared plus bx equals, and I'm going to call it c, but any number that's a constant, you want to get rid of it because we're going to replace that with our number. So when we factored, we wanted to set everything equal to 0 to factor because we were using zero product property. I want to do something differently here. So then it says, as needed, divided both sides by the coefficient of the x squared term to make sure the coefficient's 1. So a has to equal 1. So if there's a number like a 3 out here, I'd have to divide everything here by 3. Then your rule to complete the square is take b over 2 and square it. And then we're going to factor the expression. So when I say, complete the square, we want it to be the form x squared plus bx equals c. Any constants would be shifted to the other side, change the sign. Then when we go to complete the square, I like to put a little plus something here, and whatever I do to one side, I have to add to both sides of the equation. So having that little line there helps me remember to put it on both sides. A lot of people forget to balance it. All right, what number is being put there? B over 2 squared. Now, once you complete the square, then we are going to factor the variable expression, and then we're going to solve using square roots. So solve, I'm going to remind you, we're going to use square roots, and we should always have that plus or minus in our answer. Okay, so your goal is to make your function look like this, and then we can solve it in this method. All right, so here we go. First problem. I don't want to set it equal to 0, but I do want to get the x's all on one side. So I'm going to leave my x squared. I want a positive x squared. I'm going to add the 6x, and I'm going to leave a little room. I'm going to leave it equal to that 27. Why am I leaving room? Because I want to complete the square. Now, if we were doing this differently, we would have set the whole thing equal to 0, and we would have tried to factor and solve. Sometimes it doesn't factor. Now we want to complete the square. So I'm going to take 6 and divide it by 2 and square it. Well, what's 6 divided by 2? 3 squared is 9. So here's the idea. We completed the square. That's all you've done. But now I need to balance it. What you do to one side, you do to the other side. Now that I've got that done, some people want to rewrite it. I'm going to jump in and factor. This factors to x plus 3 times x plus 3. So x plus 320 squared equals, what's 27 plus 9? All right, 36. Fabulous. Now what? Well, you just made a perfect square, and now I can solve it. So I'm going to come in and take the square root, just like we did the other day, and I'm left with x plus 3 equals what? You can tell me. What's the square root of 36? 6. And because we're solving and saying what squared equals 36, we should have a plus or minus right there. That we can't forget that plus or minus. Now when I go to subtract 3, I have two different problems. I have x plus 3 equals 6. So when you go to subtract 3, we can see that x equals 3. And we also have x plus 3 equals negative 6. So when I go to subtract 3, I could also have x equals negative 9. Now, if I don't need to show that, I'm right here. 6 minus 3 is 3. Negative 6 minus 3 is negative 9. I don't need to see this extra step, but I am looking for your work to complete the square, I'm looking for your factoring and that. Okay, now look at B. What's nice about example B is the x's are all on one side and the constants on the other. That's what I was showing you, that x squared bx and the constants over there. What's not nice about B is there's a 2 out front. You cannot complete the square unless a is 1. I get a lot of people who use this 8 and then they do it. Guys, it won't factor because of the 2. So we're going to divide everything by 2. Everything on both sides. And I am left with a positive x squared, a positive 4x. I'm going to leave a little room, equals 6. Now my problem is prepped. So a has to equal 1. Okay? Now my problem is prepped, and I can come in and complete the square. But a has to be 1 before you can start. That's the rule. So I'm going to come in and take 4 divided by 2 and square it. 2 squared is 4. All right, the whole purpose of completing the square is to factor this as a perfect square. So take a second and factor it, double check that it works. Your signs are right. And I have that it equals 10. So solve it using your square root property. I now have x plus 2 equals positive or negative, and I'm stuck with the square root of 10. It doesn't have any perfect squares we can break down. And then to finish the problem, we're going to subtract 2, and it looks like this. X equals negative 2 plus or minus the square root of 10. That is the exact answer, and we did talk about it. We could find the approximate by plugging it in a calculator. Okay, so there's 2 problems for you to try. Go ahead and try those. All right, on this first one, it is not in the order we want it, so we are going to flip-flop, if you will, the 8x and the negative 2. So I need to bring this over by subtracting, and if you need to do it in 2 steps, do it, but I'm also going to move the 2 by adding. So this cancels and this cancels. We're left with x squared minus 8x. Leave a little room, equals positive 2. Again, you can do that in multiple steps. I left room so I can complete the square. I truly believe that putting the line here helps us, because a lot of times we'll put it here and we'll forget to balance it. So having that line helps us to format it, and then we complete the square by using this negative 8. So a is 1, so we're set there. We're going to take negative 8 divided by 2 and square it. That's negative 4 squared, which is 16. So that is my perfect square. And then I'm going to factor it. Now, notice I need that minus sign. So again, whatever number I squared, that is my factor. I need the 2 negatives to multiply, but add up to that negative 8x, and that equals 18. Okay, now that I've gotten it cleaned up, I'm going to come in and take the square root. And then this is really old content. This is chapter 1, breaking down roots, and what we did in 5.4 part 1. So I have x minus 4 equals the positive or negative right here, and break your 18 down. I'm going with the square root of 9 times 2, so 3 square roots of 2. And this is one of those ones where I go to add the 4 over, and my answer is going to look like 4 plus or minus 3 square roots of 2. So if you would go back in your brains when we add and subtracted roots, these aren't like terms, so we can't put the 4 and 3 together. The approximate answer we would just type in the calculator. Okay, on the next one, we have the x squared and the x set. However, we have a is not 1. So before you can do your completing the square, divide everything by 4. Now, these are working out nice. You're not getting any fractions, but if you got a fraction, you would have to deal with it. So if it was 23 divided by 4, we would have to keep the fraction and work with that. So we want to be careful there. I'm going to put in my lines just to help my brain, and I'm going to take negative 6 divided by 2 and square it, which is negative 3 squared, and I should get 9. All right, take the time to factor it and double check your perfect square factoring, and I end up with 16 here. And then I'm going to come in and take the square root. So again, this is where we have to remember that plus or minus 4. And then if you need to show it and break it down, but I'm going to show it here. I'm going to have my positive 4 plus 3, which is 7, and my negative 4 plus 3, which is negative 1. And there are my two outcomes. All right, looking at this one, I'm going to remind us again, we want it to be a 1x squared plus bx equals c. And then I am going to just remind us on the back here that we're adding in b over 2 squared. And that might be something we put on a note card. I think this is a good reminder of how to complete the square. You don't want to freeze on a test when it says solve by completing the square and you can't remember what it is. So this might be something good to take a look at there. First thing I need to do is isolate the variables by adding the 48. And so I have here m squared plus 2m, leave a little room, and that's going to equal a positive 42. Okay, now that I've got that, I am going to complete the square. And so I'm going to take 2 over 2, which is 1 squared, and I get 1. Okay, so I can factor that. It is going to be m plus 1 times m plus 1 equals 43. And then I'm going to come in and take my square root and get m plus 1 equals plus or minus, and I'm not able to break 43 down. If I'm correct, 43 is a prime number. So I'm stuck with that. I'm going to subtract 1, and my final answer will look like this. Negative 1 plus or minus the square root of 43. This is the exact answer. It says give only exact answers, so that's what we want. Always simplify your square root. If you had a fraction, you might have to rationalize it. If you want to check this, I would get the approximate answer and plug it in. Okay, when you go to do the next one, it's nice because it's preset for us. And so I'm going to rewrite it just to give myself that room. V squared minus 2v equals 3. And then we need to make a perfect square. So again, when we solved by factoring, we were setting it equal to 0. If I bring this 3 over here, it doesn't work to solve by completing the square. So you could solve this by factoring, but you would not get credit if the directions say complete the square. We are going to take negative 2, divide it by 2, and square it. That's negative 1 squared, which is 1. Okay, the difference on this one, when I factor, it's going to be v minus 1 times v minus 1 equals 4. Come in, and this is where we were yesterday, solve by taking the square root, and I get v minus 1 equals positive or negative 2. So, or add the 1 to both sides. So we have 2 plus 1, which is 3, and negative 2 plus 1, which is negative 1. And those are my two answers. Okay, if you were ever doing one of these and you had a negative number over here, at this point we would say no real solutions. And that could happen. Like if this was a negative value, could be no real solutions. And once we learn imaginary numbers, we can do it. Okay, and number 3, we have a little bit of cleaning up to do. First of all, I want to bring the x over with the x squared. I want to move the constant to the other side. So show what you need to. I know I'm going to add the 16x, and I'm going to add the 64. So I'm moving things over by adding the 16x and by adding the 64 to the other side. Now, I cannot complete the square until I get a as 1. So divide everything by 4. Now these all divide nicely, but you'd still have to deal with it if it didn't. So I'm going to have x squared plus 4x equals 16. All right, so I'm going to come in. I'm going to put my perfect square in here by taking, and don't go back to the original. The b that we want to use is 4. So 4 over 2 squared. 2 squared is 4. So be careful that you're using the right b value. X plus 2 times x plus 2, and that would equal 20. All right, now I'm changing gears. So the first gear was to prep it and then complete the square. The second thing is then to solve using square root. So we're doing 2 ideas here and melding it into one problem. So I have x plus 2. Give me a second. x plus 2 equals plus or minus, and I've got to take the square root of 20 and break it down. So I'm going with square root of 4, square root of 5. So 2 square root of 5. And then we need to write that final answer by subtracting 2. And we'll get x equals negative 2 plus or minus 2 square root of 5. So you are using a lot of different skills because you're learning your new skill to complete the square, your old skill of factoring perfect squares. Solving square roots is an old skill, but we need to refresh it with the 2 signs, and then using our idea of finalizing the answer. Okay, this bottom part is called a graphic organizer, and it's just comparing the 2 methods. So using square root versus completing the square. They both involve taking a square root, which means you would have the positive and the negative answer. And both involve writing an expression as a binomial squared. The difference is the square root property is used for only perfect squares. So if you have just an x squared or you have a quantity squared. Completing the square is used for problems that are not perfect squares. So if I told you to use the square root method, you can't unless you complete the square. Okay. Could you solve these by graphing and looking for x-intercepts? Yes. Could you possibly solve them by factoring in zero product property? Yes. But we want to complete the square.